here we have a beefier example where we actually have a division sign thrown in. Things that you want to pay attention to with this are that one thing, when we get to the restriction part, anything in the denominator at the beginning or by the end of the problem are going to be involved with our restrictions. So I'm just going to throw a little orange on them. Those are in my denominators right now. But someone just mentioned before I hit record about the keep, change, and flip aspect of this. So keep is the first fraction, x³ plus 125 over x plus 5, or rational expression. Change, the division changes to multiplication. And flip, this flips upside down, x minus 5 and x squared minus 5x plus 10. Now that is all set up. However, we have to add something in here. This right over here is now in the denominator. All right, I know it's a little bright, but this has to be considered when we do the restrictions. Okay, this has to be considered when we do them. So if there's anything that causes that to be 0, we got to think of that when we do our restrictions. Okay, now we say factor first, simplify second. This over here is the sum of cubes. We've gone over this quite a bit. On the side, I'm just going to write this as x to the third plus 5 to the third. If you need a full lesson, you either check one of our recent classes or one of the links for the class in September where we learn this. But this will factor to x plus 5 and then x squared minus 5x plus 25. That is factored to that. Again, if you don't know how to do that, you have to look back at factoring method number 3. I also reviewed it a few classes ago. Here, x minus 5 and x plus 5, there's nothing to factor with those because they are already linear factors. I'm just putting parentheses around them. Can you factor this denominator? Does anybody know how to factor this denominator right here? X squared minus 5x plus 10, or have anything to say about when you tried to factor that denominator?
I got like not factorable.
You got not factorable. Okay, so that sounds good to me. Now, if you get not factorable, something that you want to know though is, do you get real solutions if you tried to set it equal to 0 or imaginary? And that matters because if they're real, but they're those ones that have the square root in them still for quadratic formula, those get included in your restrictions because those yucky numbers are also going to be restricted. If they're imaginary, whew, life is easy because you don't even have to worry about it because they're imaginary. You just see you never buy. How do we find out if a quadratic has real or imaginary answers? We went over a way. How do you know if it has 2 real or 1 real or 2 imaginary? Who remembers how we find that out? So I'm going to write prime, not factorable. You could just shout out factor.
You figure it out by using the quadratic formula. And
what part of it specifically of the quadratic formula?
The b to the second minus 4ac.
Good, and that was called the discriminant. And we're going to check what we get for that. So b squared is negative 5 squared, or 25, minus 4ac minus 4 times 1 is 4 times 10 is 40, 25 minus 40, and we get negative 15. Who remembers what that means? Negative 15. If we get a negative number underneath the square root, what kind of answers do you have for that quadratic? We have, right, we have 2 imaginary. We love that because we don't have to worry about it. Woo, great. Not factorable, and it's 2 imaginary. That's what I'm talking about. Best type of problem. Less for us to do. Now, not that much left. Can you reduce anything? Sometimes there's not that much to reduce. What could we reduce? Just that. That's it. That is it. So what do we get for the simplified answer? You might just get x squared minus 5x plus 25 which also is not factorable. That's again in factoring method number 3. When we do the difference or sum of cubes, that quadratic, not factorable, also gives imaginary answers. X minus 5, well, you didn't get to reduce. I know that these all kind of look like they might be factorable, but they're not. You know, the numbers are just pretty close to one another and involved with each other, but there's nothing else we can do. And that, ladies and gentlemen, is the simplified answer. And the last thing, so that's simplified, simp. And the restrictions, we don't have to worry about that quadratic. All we have for a restriction is that x cannot equal what number?
And -5.
Amazing. And that right there is crossed out, so it's removable. That's it. Done. Perfect example. Okay. So what we're going to do for one homework example here is we are going to try this on our own, and it's going to be same directions as that. And we will do x to the third minus 343 over x plus 7 divided by x squared minus 49 over x squared minus 14x plus 49. So same directions. You're going to simplify, but you got to remember you should factor first. And then you're going to state restrictions. And one extra step is, my bad, describe the type of restrictions. Describe the type of restriction or restrictions. Okay, those are your directions. Simplify, rational expression, state the restrictions, and then the new piece, describe the type of restrictions. You always write down the original problem, okay? Show all of your work, and if you need any help, come to office hour today or tomorrow. Remember, tomorrow might be a little bit shortened. Check
Is this
classroom.
another keep change flip one?
Sorry?
Is this another keep change flip one?
Yep. Anytime you see fractions getting divided by fractions, you're probably going to bust out the keep, change, flip. Okay. So these videos, if they're not uploaded by the end of the school day, please pop into office hour and remind me. I'm going to try to do them right now. And if you are watching and you kind of understood that last one, thumbs up. If not, I'm sure some people are confused. Put a thumbs down. That's why I'm giving you one more very similar to it. Just boost it up a smidge. You'll get it next time, but that's what practice is for, okay?